Hi, I'm Jamie Miller, a registered SQF consultant and food safety consultant at Kellerman Consulting, and you are watching our video series on environmental monitoring programs. In this series, we have covered the simple and complex actions required in a functioning environmental monitoring program for food and food packaging facilities and how to address pathogens when discovered. In this episode, we want to shift our attention to indicator testing and quality testing, which have different requirements than pathogen testing. The most important distinction between pathogen testing and indicator or quality testing is that unlike pathogens, where we cannot have any detectable presence, we are allowed to have some presence of indicator or quality organisms. Since indicator organisms such as aerobic bacteria and coliforms are allowable in some amounts of environmental testing, we will look at how to understand testing for APC, coliforms, yeast, mold, and other spoilage organisms, as well as how to set limits on results and determine what is acceptable and unacceptable. The actions required for using swabs as part of an environmental monitoring program are the same when we test for indicator and quality testing, as we discussed in our previous episodes about pathogen swabbing. When indicator and quality testing organism swabs are prepared for zone testing, they should be scheduled, recorded, and the tests submitted to a qualified lab. One important difference between indicator and quality testing and pathogen testing is that with indicator and quality organisms, it is acceptable to swab food contact surfaces. But remember, we cannot swab food contact surfaces for pathogens unless instructed to do so by a regulator, such as with a listeria control for ready-to-eat products in a meat and poultry facility. We can swab contact surfaces for indicators or quality organisms because they are not classified as posing an immediate safety risk for end users. Indicator and quality organisms exist in food and food packaging materials, live in water and on humans, and can even be found living in the air. When we swab for them under normal conditions, we expect to find them in the test results at some level. Yeast is something we are all familiar with because of its use during the fermentation processes in breads and beverages. Mold is a decomposer we all know very well in the items we may store for an extended period of time in our refrigerators and pantries. The amounts of yeast and mold normally found in food environments are not enough to cause harm, but yeast can create alcohol in certain foods under the right conditions and can also create a bready smell or taste that is undesirable in finished products. Mold grows over time in food, and when there is enough mold in or on a food to cause harm, it is visible to consumers and as such is not deemed a poisoning risk in the way invisible organisms such as listeria and E. coli are. Because bacteria, coliforms, yeast, and mold do not cause food poisoning in humans in general, we can safely use them as a reference point in our program to see how much control of microorganisms we have. Other indicator organisms, such as thermophilic bacteria that thrive in hot conditions or organisms that grow in dry conditions, give a picture of how processes may reduce or increase certain types of organisms for quality control personnel, even if the organisms themselves are not dangerous. Most of these types of indicator testing are performed in highly developed quality control programs. When we test for indicators, the most important concern is how to set a limit to determine when there are too many of those organisms. As we mentioned previously, there is no tolerance for pathogens, so it is easy to know how to interpret pathogen swab results. With bacteria, coliforms, yeast, mold, and other indicators, we may get a reading of 50 colony-forming units, or 2,000, or 10,000. Sometimes the results are too numerous to count. When trying to determine how to set limits for indicator organisms, the quality and safety personnel should review requirements from customers to see if limits are set externally. For facilities that do not have customer requirements, setting limits should ideally be done through analyzing results of repeated testing to get a baseline or average result. If we test 5 times and get an average of 250 CFUs over those tests, we may want to set the limit at 300 or 500 CFUs. and that will prompt the team to take actions when the amount of the organism is higher than the average. You may also choose to consult with a laboratory or industry group to get a better sense of what is common in the industry the facility is in, and this is often acceptable in regulatory inspections and audits as a rationale for testing limits. However the facility chooses to set its limits for indicator or quality organisms, it is very important that remediation actions are taken when we exceed those limits. Even though an increase in bacteria, yeast, mold, or coliforms may not be an emergency, we cannot ignore results that we do not like. In a previous episode, we reviewed actions to take when a pathogen is discovered in the facility. These actions should be considered for indicator organisms where adverse results are discovered. At a minimum, the facility should clean and sanitize those areas where the elevated levels are found. This should be followed by swabbing the concerning areas after a corrective action is performed to see if those actions were effective. Lastly, we should be monitoring those areas more frequently following adverse results, and we should continue to target those areas for monitoring until we see trends that are consistently below the acceptable limits. Thank you for watching. For more food safety training videos and resources, please consider subscribing to our YouTube channel or follow us on LinkedIn.